Okay, here's a video today. Finding specific heat and heat energy using formulas, right? So there's a specific heat index used for certain materials, certain substances. So anyway, what is specific heat? That's the question. So you might find a definition like this: the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. You might be saying, What are you talking about? So basically, it's just how much energy it takes to raise the temperature of a substance. For example, think of water. Water has a high heat capacity. In other words, it takes a lot of energy to heat water. And it may not seem that way, but just think about when you're on the beach. When you're on the beach in a hot July or August, and you walk on the sand and you don't have flip flops or shoes on, the sand is extremely hot and you're running to the water. And when you get to the water, what do you find? The water is cold. And why is it cold? Because it takes a longer period of time for water to heat up. So that's what we're going to talk about today: how long it takes and what formulas we can use. And the first thing you should know is that we're going to be measuring this energy in joules. So let me write that down: joules. Joules, joules. All right, so let's get a clean page here. So let me write the formula. And the formula seems weird at first, but I'll explain it. So we have this Q. Well, we're trying to get Q here. Gotta make sure the pen's working. All right, let's see if it works now. There's Q. Make it a little thicker. There's Q. So Q represents the heat energy needed. The heat energy that's needed. It's going to equal M. And by the way, M is just the mass. And then we have C. And that's the specific heat index. We'll talk more about that. And then you have this symbol delta. It's a Greek letter delta T. And all that means, both of them together, it means the change of temperature. And it all makes sense in a minute. So you have Q equals MC delta T. Greek letter delta. Alpha, beta, gamma, delta. So let's use an example and we'll get it. Let's say you had put a line over here. Let's say you had 12 grams of a substance. Let's say silver. That's a symbol for silver, argentum. So let's say you have 12 grams of silver and you want to raise it 20 degrees. And of course, we're always going to use Celsius. 20 degrees Celsius. So if you want to find out what is the heat energy needed to do that, you need to know, if you look at the formula, let's use green, you need to know the specific heat. And there's a chart for that. If you didn't know the specific heat, then at least you have to know the heat energy. So for silver, it's 0.24, which is low. I should go back to what water is. Water is high. So 0.24, where water, maybe we should use blue for water. Water, one of the highest on Earth, actually, is a 4.184. Making my fours a little different there. So you can see water as a 4. Just think of it as 4, where silver is 0.24. It's not even near 1. So water is a lot harder to heat up than silver. So once we know our specific heat, we can just plug it in. We find out what Q is. Q is going to equal the mass of 12 times C, which we know now is the specific heat, which is given to you, 0.24. And then what's the change in temperature? Well, it's 20 degrees. We're changing it 20 degrees. Put all that together. Just multiply it. What would you get? Try that. So if you multiply all that together, you're going to find that the heat energy, Q, this heat energy, is going to be 57.6 joules. That's how much heat energy you need to raise 12 grams of silver 20 degrees. Let's do another one. Clear it out. And back to the water. You're on the sand. Sand has a specific heat of 0.19. That's sand. So you can see how it gets hotter much quicker. Let's get our English right there. Where again, water, we're in 4.184, much higher. So on Earth, you got to think of things like hydrogen. That gas hydrogen has a much higher one than water, but not much does. So let's look at another question. Let's say you have the heat energy already. Let's just go back to the question we had just to make sure we understand how to do it if we wanted to. Remember, we found that silver had a 0.24 specific heat, but let's say we didn't know that and we wanted to get that. So let's say we have 57.6 joules. This is from our other answer before, of energy. Well, we don't have this, but let's say 57.6 joules of energy is needed to raise the temperature of silver 12 grams of silver. So we'll say the temperature of silver 12 grams, and we'll say 20 degrees. And we wanted to find what is the specific heat. What is the specific heat? We already know the answer, but you might get questions where you have to try to find it. So we have to make sure we get 0.24. Let's change the color. And let's write the equation again down. You should know it. It's Q, that's the heat energy. M is the mass. C is the specific heat. And delta T, change of temperature. So let's say what we have. We have 57.6 equals, because that's Q, that's the heat energy. We have the mass of 12. We don't know the specific heat, even though we do know. We'll just put a C there. And then we're timesing it by 20. So just doing a little algebra here. So if you do that, you'll get 57.6 is going to equal 12 times 20, which is 240, right? And then just do a little algebra. Whatever you do to one side, do to the other. And you're going to find that C, well, is 0.24, right? That's exactly what we said before. One more question. Why not? All right. Let's say we had 21. If we get our pen working, we can have 21. 21 joules of energy. Right? 21 joules of energy is needed to raise 5 grams of mercury. Right? Hg is mercury, a Latin word. Hydrogen, fancy word, right? By 30 degrees. Now, sometimes they don't just tell you the degrees. They'll say let's say from 10 to 40. And from 10 to 40, we know is 30 degrees. And, of course, we are using Celsius. So find C. See if you can do that. Find C. And what is C again? The specific heat. Sometimes it's given to you, and you have to find Q, which is the heat energy. Or sometimes you have to find the specific heat. So why don't you pause, try to do it. Pause the tape if you want to. Here's the formula. Q, M, C, delta T. Sounds like the MCATs if you're a doctor. So we already know Q, right? So Q is 21. The mass is 5. We're trying to find C. And the change of temperature is 30. So we're going to have 21 equals 150 C. And we'll just divide 150 on both sides. Do a little algebra. Cross out so your math teacher doesn't get mad at you. And the specific heat of mercury, hydrogen, is 0.14. All right. So those are the formulas for specific heat and heat energy.